Hello, everyone. This is Anil Sachdev from the General Motors Research and Development in Warren, Michigan. And I'd like to take this opportunity to thank the awards committee of the International Magnesium Association for selecting our entry, die-cast magnesium door upper beltline reinforcement, in the automotive cast product category. This high-pressure magnesium die casting was a collaborative effort between General Motors and Meridian Lightweight Technologies and is currently in production in the 2020 Chevrolet Corvette. This casting application represents an industry-first application for magnesium in a beltline reinforcement. This reinforcement casting was designed with magnesium alloy AM60B with a nominal wall thickness of 2.5 millimeters. And it also had ribbing to meet performance requirements. The magnesium casting measures about 1200 millimeters in length, 120 millimeters in height, and 160 millimeters in depth, and weighs about 1.9 kilograms. The beltline reinforcement provides for a 4-kilogram mass savings per vehicle, which is a savings of about 50% from the multi-piece, multi-material design that is used earlier. The unique casting replaced this 5-piece multi-material design that was used earlier with 3 materials, steel, aluminum, and SMC, that needed 5 tools and 3 separate joining operations, and represents a power of die casting to replace it with 1 piece by up integration and parts consolidation. The continuous beltline structure has several advantages. The first one is by putting material where we need, especially in the corners, we avoid the door opening to resist elastic deformation when it opens into a stop where the force tries to uh, deflect this rectangular shape into a trapezoidal shape. And what the casting enabled us is to add the material where needed to avoid this particular situation, and that improves the durability of the door. The window glass passes through this opening in the casting. There were several innovations in the die casting, key being the innovative S section. This is a cross section of the casting that I show here. This is an innovative S-shaped in the casting, and a ribbing on the opposite side, which then provided high stiffness and fracture robustness in the critical locations under high strain rate vehicle side impact. This again exhibits the benefit of castings to put the material where needed. Separately, the casting design innovation obviated the need for slides and subcores by orienting the casting to define the inner and outer surfaces of the casting by the 2 die halves. The casting design also enabled full powder coat coverage through a monorail paint line process, with no pockets for fluid collection and therefore corrosion concerns. The ability of the casting to add material where needed, especially at the location of the rear view mirrors, provided high local stiffness that enabled an industry-first thin arm pedestal mirror, which is a key styling enabler. And here you can see this pedestal mirror on the door that is actually bolted directly into the die casting. And that is provided the only attachment point for this rear view mirror into the door. The casting also provides attachments for glass seals, and you can see this glass seal is attached directly to the S-shaped casting cross section that I showed earlier. And it also allows for attachments for the window regulator directly into the casting. Finally, the Class A outer panels were bonded directly to the casting, which eliminates the need for an intermediate retainer. Once again, many thanks to the International Magnesium Association and to the awards committee for selecting this die casting for an award. We hope that applications such as this will spawn more automotive magnesium applications in the future. Thank you.